Hello friends, welcome to the channel. Today we are going to solve the problem length of the longest subarray with positive product. Here the problem statement is given an array of n integers, find the length of the longest subarray with the positive non-zero product. So we are given an array, we have to find the length of positive non-zero product. So we have to exclude 0 and we have to return the longest subarray with the positive non-zero product. They are not asking the highest product, they are asking the longest. Now the subarray is any subset of this array which is contiguous. So for this array, the subarray would be null set or 0 or 0 1, 0 1 2, 0 1 3, 2 3, 0 1 2 3 4. So only contiguous elements would be considered subset. If we consider 2 minus 2 and minus 4, they won't form a subset. Okay. Now, so let's try to understand the problem more clearly. For that, let's move on to whiteboard. Okay, let's take the example 1. We have 0, 1, minus 2, minus 3, minus 4. The answer would be for this is this subarray. 3 2s are 6. 6. But they want the length, so answer would be 3. 1, 2 and 3 elements. We won't include this because if we include this, the answer would become negative and they want the positive, longest positive subsequence or subarray. Now, how to approach about this? There are multiple methods through which we can approach this problem. The brute force solution of this problem would be to just simply run two arrays of to run two loops and calculate all subarrays and all the products and then choose the subarray with the maximum positive subarray with maximum element and largest product. So that's one approach where we can, let's write the approach. We can run one for loop from 1 to n. This would be I, then another for loop j from I plus 1 to n, and this will calculate all the subarrays, and all we have to do is just keep calculating their product and number of terms, the product which is, and we have to choose the positive non-zero product with maximum element. But the problem with the solution is the complexity of this solution will be of big O n square, n to the power 2, and which is very high. Uh, if you see in the problem statement, they are asking the expected time complexity is big O of n. So you have to bring this complexity down to the linear term. So here's a trick solution to do that. We have multiple methods to calculate the sum and product of sum using Cadine's algorithm and multiple more methods, but here we have a simple one. To solve this, what we will do is we'll count the negative. We'll count the number of negative elements in the array, and if we see, the problem is in product, if we have two negatives, they form a positive. Two negative is equals to positive. So what we have to do is count the number of negatives, and if we the number of negatives is positive or it's even, if the number of negatives is even, we have to deal that accordingly, and if the number of negatives is odd, then we have to deal that accordingly. If the number of negatives is odd, now we have two cases. Let's go to whiteboard. Now we have negative count. So it can be either even or odd. So if we have, let's consider the last example again. 0, 1, -2, -3, -4. So here we'll exclude the 0 and consider this subset. Now 1, 2, 3, 4. We have 4 elements. Among the 4 elements, if we have 4 non-zero elements, then we'll count the negative. If negative is even, then the number would be positive, and that would be our answer. But if the negative is odd, then that means we have one extra negative which we need to tackle. So the if we remove that, then the number would be even, and that would be our solution. So we'll just minus the negative element from the answer and we'll get our answer. Suppose the length is 4. Remove the negative element and answer would be 3. Is it clear? I hope it is clear. If you still have any doubts regarding the explanation or approach, do ask in the comments. Now let's see the code and things would be more clear to you. So what we'll do is we'll first take few variables. Let's take one start variable. Initialize it with 0. Then another variable which will count negative, which would be 0. Then also we do need to know the first negative element. First negative, let's initialize it with -1. That means we don't have any negative. And finally answer, which is also 0. Okay, we got our variables. Now let's start a loop. 0 to less than n. Now the first thing we'll encounter or tackle is if we get 0. If we get 0, what we'll do, we'll reset everything. Start equals to I plus 1 so that we could ignore that element and move ahead in the array. Now first negative would go back to its initial value, count negative will go back to its initial value. And since we have encountered 0, we don't have to do anything in this iteration, so we'll just continue. Now if we encounter a negative element, so in that case, sorry, yeah, first we'll count it, count negative plus equals. Now if this is if first negative, so if this is first negative for this subarray, then we'll update this. That's it. That's the logic. Now we have to do is check if count negative mod 2 double equals 0. It means we have positive number of negative elements, which also means that the end result would be positive. So we just have to update the length. So math dot max answer comma answer, which is currently 0, but eventually suppose we have a longer array and we have encountered a 0 in somewhere between. So we have considered the first half of the subarray. Now we are considering the second half. For that we could tackle it like I minus start. Start would also be updated when we encounter 0. So I minus start. Now see, if we have an array which is indexed from 0, so it would be elements would be 0 1 2 3. Now see, we have 4 elements. So if I is here, I is at 3 from 0, so the total number of elements would be 4. So that's why to tackle that one missing element we have to do 1 plus 1. I hope everything is I'm able to explain it. Please feel free to ask any questions in the comments, of course. Else, so this is when we have negative number of negative elements. We have odd number of negative elements, for example. So that will in result, or that will in the end cause the whole output to go negative. Uh, in this case, suppose in this case we have odd, so we have to exclude this one. Otherwise, the whole output would be negative. So we'll exclude this one, and our answer would be this 1 2 3. Okay, so how to exclude it? See, we'll take maximum of, let's say, comma I minus first negative. So whenever we have encountered the first negative, we'll just remove that, and it is done. Suppose, see, if you include this, then count it means one negative element is included and the output is odd. So if we know the location of first negative element and we remove that, suppose we have reached in the end to, while traversing the array we reached in the end. Now we have to calculate the output, so we just have to remove the last element, first negative element, and the remaining array would be positive. So that's why we have done this, and that's it. This is the solution. Return answer. Check whether we have done some error or not. Compile. It's correct. Let's submit it. Tada! Accepted. So this is it. This is today's question and the solution. This is an array problem of medium difficulty. So what I'm going to do now is I'm going to upload more questions in a different playlist related to arrays, where we'll be discussing similar algorithms related to array problems, where we can optimize the solution using Cadence and some other array algorithms. So I'll be creating a playlist and we'll discussing more problems on that. So do consider subscribing and following. Stay tuned. Thank you so much.